Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel and get alerts. If you like this, please hit the like button. Now let's see the circular laminas or circular planes making angle with both the reference planes. Let's take an example, a circular lamina of 50 mm diameter resting on one of its points of the circumference. A point on the circumference is lying on HP and its surface making angle with the HP. Let's see that. So the plane is taken in the horizontal plane and its surface making 30 degrees angle with HP. And here on this circumference, on this a point is here on one side you have a point and this point is lying on HP. And the diameter which is parallel to HP is making an angle 45 with the VP. The diameter here, if you see this line, this diameter is parallel to HP. This diameter is making angle with the HP. Okay, this is the one. This one is making angle with the HP, that is this one. And here perpendicular to that you have another diameter, it is parallel to HP. This diameter is making an angle 45 degrees with VP. So it will be like this. So if you take this diagonal, the diagonal is making 45 degrees angle with the VP here in the top view. And in that position, the front view appears like this. So these are the final projections of the plane surface, a circular lamina. Now let's draw the projections. So draw the reference line. Now take the plane in the horizontal plane or parallel to the horizontal plane. Because its surface is making angle with the HP, take the plane in the parallel to the horizontal plane. That is, in the top view, we see the true length of the true length and the true shape of the circle. So draw a circle here and show the dimension, right? That is 50 mm. Now coming to this circle, here we need to take the points on the, if it is a polygon, we have the corners. But here on the circle, we don't have any points on it. It's a smooth curve. So we take number of points on the curve by dividing the circle into some 8, 12, 16 number of parts, equal parts. So here we divide this circle into say number of parts here and mark them here like this. Okay. So it is divided into 8 parts only here for not to have congestion. So here better you take 12 parts. Then you get 12 points and that you will be getting a smooth curve. So here it is divided into 8 parts here and all the points are marked as A, B, C, D, E like this. Starting from one end, generally from the left hand corner, left hand extreme point is taken A, and either clockwise or anti-clockwise we mark the points. Here anti-clockwise the points are marked like A, B, C, D like this. Now let's draw the front view. And here coming to this, because the surface is making angle with HP, we have to take the plane parallel to HP. Because we have a point resting on the horizontal plane, take the plane not just parallel, it is in the horizontal plane itself. So draw the front view here from A dash to C dash. This is the front view. Now it's show the surface angle with the HP. Same length is taken here. The same front view is redrawn here at 30 degrees angle. That means its surface is making an angle 30 with the HP. Mark the same points here in the front view. Now draw projectors from all the points here from the front view and draw horizontal lines from all these points here. They will intersect here at number of points. Mark the corresponding intersection points like from A dash and here A. This point is A. Likewise B, C, D and all the other points. Join all these points by a smooth freehand curve. So here why I told you to take 12 parts here or 12 points on the circumference on the curve is when you are drawing the smooth curve, freehand curve, if you have the points nearer by, then the curve will be smooth. Right? Otherwise, it's even difficult to join the curve between the 2 points which are at a distance. So, better to take the points nearer by, at least 12 parts on the circle. Now we got the curve here in the top view. Now the diameter which is parallel to HP, we have two diameter lines. We can talk about two diameter lines. One is AE, other one is GC. GC is one diameter and AE is one diameter, another diameter. Here AE is making an angle with HP already. So coming to this GC, GC is a point in the front view and here is a line perpendicular to the VP or parallel to HP. Now we are talking about this diameter, parallel, which is parallel to HP, is making an angle 45 degrees with the HP. Actually, you can even mention this about the diameter GC is making angle like that, right? Or here, without mentioning the names of the points, the problem is given. So this GC diameter is making an angle of 45 degrees with HP, with VP. This GC is parallel to HP. So we draw a line here at to show that GC at 45 degrees angle, it is rotated like this. So take the top view here and rotate it to the required angle such that this GC line will be at 45 degrees angle to the VP. So this is the GC now. So let's draw it. Take a line here at 45 degrees angle. Mark these GC points here on this line. G and C points should come here on this line. And with these 2 points as reference, get all the other points by taking the distances here in the top view. So join all the points by a smooth curve. You get the same top view here in a different position. Only it changes the position, that's all. Otherwise, the same, this top view and this top view both are same. There is no difference. Now, let's draw the front view here by drawing projectors from all the points here. Draw projectors and from this front view, draw horizontal lines and these will intersect here at number of points. Join all the points by again, mark these intersection points first. Join these points continuously, A dash, B dash, C dash like this. All the points are joined by a smooth freehand curve. You get the curve like this. So this is the front view. So here these are the final projections of the circular lamina when it's a surface making angle and one diameter line is at some angle. So actually the surface is actually making angle with both the reference planes. That's how we get the final projections. Now, let's take another example. A circular lamina of diameter is given, resting on one of its points of the circumference in HP. Like point is on the horizontal plane, so that we should take the plane in the horizontal plane. Its surface is making an angle 30 with HP, surface angle with HP. So the surface angle is shown here, 30 degrees angle, one point here on the horizontal plane. The diameter passing through the point on which it rests on HP. That means here the point is this one and we have a diameter line passing through this point on which it is resting on HP. So through this point we have only one diameter and this diameter is appearing to be at 45 degrees angle with VP. What is this 45 degrees angle? Can you identify? Already this diameter line or this line, straight line, which is the diameter, is making an angle 30 with the reference line. Forget about the circle. Take just the straight line here and it is making 30 degrees angle with the HP. Now, this 45 degrees angle will be apparent angle because this line is already making an angle with the HP. When you take the line here at this line, this diameter is taken here, that will be the 45 degrees angle, that will be the apparent angle. And in that position, the final projections of the plane surface is like this. The plane appears like this in the front view and top view. Now let's draw the projections. Draw a line here, reference line, draw a circle in the top view such that we can make the surface inclination with the HP. We should take the plane in the horizontal plane because one of its points of the circumference is in HP. Now show the dimensioning. Diameter is shown here and divide the circle into 8 equal parts. 12 in your case, at least 12. So here I have taken 8 parts, mark them from A to H and draw the front view here, projectors from the top view and draw the front view. It's a line, appears like a line in the front view. And now mark these points here, starting from A, corresponding points are marked. F, G, H are in the brackets because these 3 points are away from the observer who is looking in this direction. So these are kept in brackets. Now to show the surface inclination 30 degrees with HP, draw a line here at a 30 degrees angle, mark the same length here on this line, and this is the 30 degrees line. Mark the points, you get the same front view but in a different position at some angle. Now let's draw the top view. Draw projectors from all these points. Draw horizontal lines from all these points. All these will intersect here at a number of points. Take the corresponding point. You have to be very careful. You take this A line from A dash and a line from A. This is the point A here because it is the top view. Mark A, B, C, D, E, F like that. So mark all the intersection points, join them all by a smooth freehand curve because it's a curved surface. You join all the points by a smooth freehand curve. Now here comes the next position, next case. The diameter passing through the point on which it rests on HP. Here for this circle we can talk about 2 diameter lines. One is AE, other is GC. GC is actually parallel to the horizontal plane. Even here, if you see this GC is parallel to the horizontal plane, whereas AE is making an angle with the HP, already making an angle with HP. Now, if you see this AE line in the top view at some angle, that will be the apparent angle. So here we have to show this as apparent angle and draw a line here at this is the way of moving the circle. So rotate the circle here by in the anti-clockwise direction like this, such that this AE line, AE diameter line will be at 45 degrees angle, appearing in the top view as 45 degrees. Now, this is the way of drawing it. So let's draw this by taking a line here at 45 degrees angle. On this 45 degrees line, we take this AE. So AE is marked here. AE is marked here. And by taking these 2 points as reference points, we mark all the other points here. Okay. Now, let's draw the front view. Draw projectors from all the points. Draw horizontal lines from these points. Mark the intersection points here. Join all these points by a smooth freehand curve and you get the curve like this, joining all the points. So once you complete it, our final projections are ready. This is the final front view and this is the final top view. Okay. So here one thing you have to observe is what is this angle, given angle with VP? When it's already making an angle with the HP, the other angle which you are showing for that particular line will be the apparent angle in the top view. So be careful in showing that And these are the final projections of the circular lamina. Next, let's take another circular lamina, 50 mm diameter, resting on a point of its circumference in HP. Okay, its surface making an angle 30 with HP. Fine. And okay, let's show that the circle is shown here and the surface angle with HP, and the diameter through the point on which it rests on HP is appearing to be at 45 degrees angle. Okay, and the point A on which it rests on HP is nearer to VP. It's the same as the earlier problem, but there in the previous problem we have taken this. If we suppose if this is AE, this E is taken nearer to the observer, but in this case the A, this point is taken nearer to the vertical plane. So that is the only difference. Otherwise, this problem and the earlier previous problem are both are same. So let's see how to draw this one. Draw reference line, top view is drawn. So already we have seen this. Show the top view here, mark the points, name them, get the front view, show the surface inclination with HP, mark the front view, draw vertical lines, projectors here, and horizontal lines, get the intersection points, join them by smooth freehand curve, you get the top view. Now here comes, in the previous problem, we have rotated the point here by taking the point A. We have rotated this in the anti-clockwise direction. But now let's rotate this in the clockwise direction such that this point A will go nearer to the reference line or vertical plane. Okay. So to get that, we are taking the angle here in this direction. Earlier we have taken in this direction. Both are same. Absolutely, there is no difference at all. But the plane appears to be in a different position. That's all. Okay. So we have taken a 45 degrees line here. On this, we mark AE. AE, while marking AE, point A is taken nearer to the vertical plane. That is reference line. So while rotating, the plane appears like this. You'll be rotating in the clockwise direction such that the point A goes nearer to the vertical plane. Now let's do. So this line AE should come here on this. So we have taken the AE here. This AE is taken on this line, and by taking these 2 points as reference, we have marked all the other points, joined them by a smooth freehand curve. Now this top view and this top view both are same. Absolutely, they both are same. There is no difference at all. Only thing is we have redrawn the same top view here in a different position. That's all. Okay. AE is here parallel to the reference line. But now here it is taken as at 45 degrees angle to VP. That is the only difference. Otherwise, the same top view is reproduced. Now, let's draw the front view. Draw projectors from all the points. Draw horizontal lines. Mark the intersection points. Join all them by smooth freehand curve. You get the front view. So these are the final projections of the circular lamina when its surface is making angle with both the planes. Okay. Hope you had understood this topic very well. And if you have any queries or any doubts, you please do comment, like, share, and subscribe. Thank you.